Lesson: Predictive modeling techniques for identifying supply chain risks. Predictive modeling techniques have become pivotal in identifying and mitigating supply chain risks, leveraging data-driven insights to enhance decision-making and risk management strategies in complex supply chain environments. The application of these techniques involves the use of statistical algorithms and machine learning models to anticipate disruptions and assess their potential impact on supply chains. By doing so, organizations can proactively address vulnerabilities and optimize their operations. One of the primary tools in predictive modeling for supply chain risk management is the use of machine learning algorithms. These algorithms analyze historical data to identify patterns and trends that may indicate potential risks. For example, regression analysis can be used to identify relationships between different variables in the supply chain, such as supplier performance and delivery delays. By understanding these relationships, companies can predict future disruptions and implement corrective measures. Another effective predictive modeling technique is decision tree analysis. Decision trees help in mapping out various possible outcomes of supply chain decisions and the risks associated with each path. This method is particularly useful for evaluating the impact of different risk scenarios and identifying the most effective risk mitigation strategies. For instance, a company might use a decision tree to assess the potential consequences of sourcing materials from a new supplier, considering factors such as cost, reliability, and geopolitical risks. Machine learning models, like neural networks and support vector machines, offer advanced capabilities for predicting supply chain risks. These models can process vast amounts of unstructured data, such as news reports and social media feeds, to detect early warning signs of potential disruptions. For example, natural language processing can be used to analyze customer reviews or supplier communications to identify emerging risks related to quality or reputation. The use of simulation modeling in supply chain risk management provides a dynamic way to test different scenarios and evaluate their impact on the supply chain. Monte Carlo simulation, for example, involves running thousands of simulations to assess the probability of different risk events and their potential consequences. This approach allows companies to quantify the likelihood and impact of risks, enabling them to prioritize mitigation efforts. In practice, implementing predictive modeling techniques requires access to reliable data sources. Organizations must ensure that they have robust data collection and management systems in place to gather accurate and timely information. This data may include internal data, such as inventory levels and production schedules, as well as external data, such as market trends and economic indicators. Ensuring data quality and completeness is critical for the success of predictive models, as inaccurate or incomplete data can lead to incorrect predictions and poor decision-making. A practical example of predictive modeling in action can be seen in the case of a global consumer goods company that faced frequent disruptions in its supply chain due to supplier reliability issues. By implementing a predictive model using historical data on supplier performance, the company was able to identify high-risk suppliers and develop contingency plans to mitigate potential disruptions. This proactive approach allowed the company to maintain supply chain continuity and improve overall resilience. Another case study involves a major automotive manufacturer that utilized machine learning to predict and manage risks associated with fluctuating demand and supply chain capacity constraints. By analyzing data from both internal systems and external market sources, the manufacturer developed predictive models that accurately forecasted demand spikes and resource shortages, enabling the company to optimize inventory levels and production schedules. Moreover, predictive modeling techniques can be integrated with other risk management frameworks to enhance their effectiveness. For instance, the integration of predictive analytics with the failure mode and effects analysis framework allows companies to prioritize risks based on their likelihood and impact and develop targeted risk mitigation strategies. This combined approach provides a comprehensive view of potential risks and enhances the organization's ability to respond effectively. The successful application of predictive modeling techniques also depends on the skills and expertise of supply chain professionals. Organizations must invest in training and development programs to equip their teams with the knowledge and skills needed to effectively implement and manage predictive models. This includes understanding the underlying statistical and machine learning concepts, as well as the ability to interpret model outputs and translate them into actionable insights. In conclusion, predictive modeling techniques offer a powerful toolset for identifying and mitigating supply chain risks. By leveraging data-driven insights, organizations can enhance their risk management capabilities and improve supply chain resilience. The integration of machine learning algorithms, decision tree analysis, and simulation modeling provides a comprehensive approach to risk identification and mitigation, enabling companies to proactively address potential disruptions and optimize their operations. To effectively implement these techniques, organizations must ensure access to reliable data, invest in training and development, and integrate predictive analytics with other risk management frameworks. By doing so, they can enhance their ability to anticipate and respond to supply chain risks, ultimately improving their competitive advantage in a rapidly changing business environment.